Welcome to homework.
Okay, we have this cyclohexane derivative, and what we need to show is the products resulting from the addition of HBr across this double bond system, conjugated double bond system, specifically showing the 1,2 and 1,4 addition products. And we need to assume that both are derived from the most stable carbocation intermediate. Recall that in the first step of the addition of HX over a double bond, one side of a double bond will get a hydrogen, whereas the other side will get a carbocation. So when we look at our substrate, we have to decide where the most stable location would be for a carbocation if we were to add HBr across it in the intermediate step, in which we have hydrogen added to one side of a double bond and a carbocation on the other, meaning identify the substitution pattern of each carbon, meaning this is secondary for having 2 bonds to carbon. Likewise, this is secondary. This is tertiary, right? 3 bonds, 3 neighboring carbons, and this is primary. So in terms of the most stable location for a carbocation, that would be this tertiary carbocation here. So we're going to assume in the first step of the reaction that is where our carbocation will have been located. So the intermediate that we're interested in now then looks like this. And so then the 1,2 product, in reference to the location of the hydrogen, if we call this carbon 1, the 1,2 product would mean the immediate addition of bromine at carbon 2. Right, so the 1,2 product will look like this. And we wouldn't typically draw the hydrogen, which is on carbon 1, right? Especially not in a program like this. So the 1,2 product would simply look like this. Okay, there's our 1,2 product. And our 1,4 product, again, in reference to carbon 1 being the carbon that got the hydrogen, 1, 2, 3, 4, would involve bromine adding to this carbon. And the way that happens mechanistically is that the double bond moves over, which shifts the location of the carbocation. Our hydrogen is still here on what we're calling carbon 1, but now our carbocation is located on what we're calling carbon 4, which is where our bromine will add mechanistically, like so. Right, so then the 1,4 product looks like the following. Again, we would not typically show the hydrogen on carbon 1 in a structure sketching program. So this would be our 1,4 product. Oh, I forgot the double bond right there.